Alright, so let's talk about some different types of data or data sets and how to showcase that data. So the first thing we want to talk about is numerical data. Numerical data is just what it sounds like. It's data that's numbers. Okay, so it's something that can be counted. So we want to look and try to see what is numerical data here. Number of jelly beans in a jar. Yeah, I can tell you there's 10,000 jelly beans in a jar. That can be counted. The height of all basketball players. Yeah, I could measure out all my basketball players and calculate out their height. That's a number. Favorite color of all freshmen. Colors are not a number, okay? Blue, red, black, I can't do anything with that. They're not a number, they're a category, so this would be a no. The time it takes for each student to stand in line during lunch. That's a time. It takes you 30 seconds. It takes you 3 minutes. That's a time. I can calculate a number. Categorical data are like sets, okay? So it's something that can't be counted. So for instance, ice cream flavors, favorite ice cream flavors. If your favorite ice cream flavor is chocolate chip cookie dough, I can't count that, but that is a category. So this would work. Points scored by the Lakers during the month of January. I can count the number of points they score. So that would be back in our numerical set. Types of pets owned. You can own dogs, cats, birds, fish. That's a type. It's not, and it's a category, but it wouldn't be a number. College each senior plans to attend. Again, your colleges, there's different categories, there's different schools. It's not something I'm counting. It's a pure number. Okay? Next thing we want to do is we want to make our dot graph, our dot plot for this data. Okay, so we're given the different frequencies here for this data set, and we just want to plug in our different data sets. Okay, so this is our number of pets, 0, and this tells me I have a frequency, so that means how many times it happens of 4. So at 0 I should have 1, 2, 3, 4 dots. 1, 3. At 1 I should have 1, 2, 3 dots. At 2 I should have 4. At 3 it says I have 2 dots. And I get, 4, I have 1 dot. And then there's kind of this outlier here, right? We're jumping all the way up to 8 and I put 1 dot in. That's all you got to do for a dot plot. This is very similar. This is a histogram. A histogram is the bar graph. So for instance, I start out from my 0 to 3 and it says a frequency of 10. So I'd make a bar that goes all the way up to 10. If you want to color it in, you can. And I'll alternate colors just for ease of seeing. 4 to 7, again, my frequency is 10, so I'm going to come up here. 8 to 11, I'm going to go up to 8. Oh, did I miss 8? There we go. I think that's a better 8. 12 to 15 would be about there. That's 7. 16 to 19, I'm only going up to 2. 1, 2. And then same for my 20 to 24. So it just makes the bars, you go up to whatever height the frequency is at. The next thing we're going to talk about is interquartile ranges. What is a quartile, whatever. So a quartile is a quarter of the data. So for instance here, a school in Springfield recorded a number of rainy days per month for each month during the school year. The data is shown below. Okay. So what it wants us to do is, based on the collection, what is the upper quartile of the numbers of rain given each day? To do a quartile, it's the median basically. So the first thing I need to do is organize my data. So I have a 6, 10, 2 15s, 17, 18, 20 and 22. 2 22s. Okay. What I want to do is figure out what is my median, what is my halfway point to start off with. So 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. 17's right in my middle here. Okay. So now I have my lower quartile, Q1 is what we'll call it, and my upper quartile. What I do is I deal with these two pieces independently. So I treat 18 to 22 as its own piece of data, and I'm going to find the median of that, because this first one wanted the upper quartile, sorry, Q3. So if I'm doing this, I cross out, and I have my 2 in the middle, so I'm going to add them together and divide by 2, which would give me 42 divided by 2, which is 21, which would be my answer over here. To do number 6, it now asks about the lower quartile, which again is the bottom half. We're going to find the median of that bottom half. Cross out 6, cross out 15. I'm going to add these together, so 10 plus 15 over 2. 25 divided by 2 would give me 12.5. So it's just breaking down your median into different parts. Based on the collected data for number 7, the interquartile range of the number of days of rain for each of the 9 months. Interquartile range, is going to be the 21, so it's our upper quartile, so Q3 minus Q1. 21, I don't know why I just made that 12. 21 minus 12.5. Okay, and that would give me the 8.5 as my answer for my interquartile range. So it's just like range, high minus low. You're just using that quartile data to be able to find that. And our next one, what percentage of the data falls between 12.5 and 21? So if we almost think about this visually, right? Do this. 12.5 would land about here, and 21 is about here. And that's about half of my data. That's what these upper quartiles give you, is what would fall between that two brackets. There's some outliers on either side, but it captures about 50% of the data. Okay. So next, is this the same numbers? Do I have to reorganize them? So same data set, so I don't need to redo everything. I already had it in a nice order. 6, 10, 15, 15, 17, 18, 20, 22, 22. So our 5-number summary that you will see. Minimum, that's just the smallest number. That's our 6. 6 is our smallest here. Maximum is our biggest number, the one that comes out on top. Okay. We already found our Q1 and Q2. That was that upper and lower quartile. So my Q1 here is 12.5. And my Q3 I calculated to be that 21 over there. And the median is our original middle. So if you wanted to like double check what your actual middle is, well, it's that 17 that we kind of blocked off previously. So 17. Okay, that's a 5-number summary. Minimum, Q1, median, Q3, and maximum. It says, draw the box plot to represent this data. Label the 5-number point summary from question 1. Okay, so when you're drawing a box, you go for your median first. So we're going to make a line there. You're going to go up to your Q3, which is here. and you connect to make a box that way. We're going to do our same thing for our first quartile, so 12.5. So right now I have the median, Q3, Q1 that I've labeled. And to do your max and minimums, they just end up being little whiskers is what we call them. I normally call this a box and whisker plot. But my maximum is up here, oops, at 22. So I make a little whisker like that. And my minimum is all the way down here at 6. And you would just connect off that way. So min and max. And that is some different quartile range data. If you have any questions,